Now, how do you write chemical equilibrium constant for a reversible reaction? Very easy. The simple formula here is this. Watch this carefully. The equilibrium constant for a reversible reaction, that means a reaction that proceeds from both directions. As you can see, this reaction can proceed to the right. It can also proceed to the left. So if you want to write the equilibrium constant for a reaction like this, simply do this. It is equals to the rate constant for the forward, yes, for the forward, divided by the rate constant for the waiting, for the backward. That is the general formula for writing equilibrium constant for a reversible reaction. Now, what is the forward? It simply means the one in the right hand side. The backward simply means the ones in the left hand side. But what you must take into account is this, very important, that if I'm to write the equilibrium constant for pure water, that's H2O, for instance, H2O, in its liquid state, if I'm to write the equilibrium constant for water, it must be equals to 1. Yes. So the rate constant now for H2O that is in a liquid state is equals to 1. If I'm writing the equilibrium constant for a solid as well, it's still equals to 1. That means if I have CaCO3, which is a solid, if I want to write the equilibrium constant, it will be equilibrium constant of CaCO3 equals to 1. So it should be noted that pure water, that's H2O, and solid has an equilibrium constant of 1. So if we look at this reaction, we'll see that they are just gas. So none of them is equals to 1. So how do you do it? Very easy. It is the forward divided by the backward. But how do you write the forward? This is what we simply do. What you have here is ammonia, NH3. Put it in a what? In a curved bracket like this. Raised to the power of the coefficient, which is what? 2. Divide by the what? Backward. For nitrogen, you have N2. It has no power, so you can either put 1 or you don't put at all. So there's no need putting 1 here. Then here you have hydrogen. So you have hydrogen, H2, raised to the power of what? Of 3. So take note, it is forward over what? Backward. Now do this for me. Do this.